Hello, Earth Science class. So because I'm out today, I'm going to give you guys a little of a video on this slide presentation. Yesterday, you guys modeled different tectonic plate boundaries, and so I'm going to talk a little bit about what tectonic plate boundaries are and what the different boundaries are and how they have an effect on the land around them. So this is just a little bit of review. This is just talking about mantle convection and how mantle convection moves plates. So this is something we talked about a lot in class. So here we have the layers of the Earth, and we have the mantle, which has convection currents. So these convection currents, since they're right next to the crust, they're touching the mantle is touching the crust. Because the mantle is moving, it pulls the crust along with it. And notice here we already have an idea of what plate boundaries might look like because these two currents are opposing each other. They're going in different directions. So they're pulling one part of the crust in this direction, one part of the crust in this direction. In other words, this is a boundary where two plates are moving away from each other. Whereas on the left or the right, we have mantle convection currents meeting each other. They're moving towards each other, so they are making two tectonic plates collide with each other. So this picture here is just kind of an overview of what the globe looks like with all the different plate divisions: North American plate, South American plate, African plate, Pacific plate, etc. So lots of different plates. And again, these tiny red arrows indicate the direction the plates are moving. So right here on the west coast of America, we have the Pacific plate moving up toward the northwest, whereas the North American plate is moving toward the southeast. So these two plates rubbing up against each other. It's called a transform boundary. We'll get to that in a second. So there will be some effects there. Right here, the Indian plate is pushing to the north. The Eurasian plate is pushing to the south. So again, there's going to be some consequences because these two plates are colliding into each other. So it brings us to the topic of today and yesterday. There are three types of plate boundaries. We have divergent. Divergent is when two plates are moving away from each other. Convergent is when two plates are moving toward each other. And then transform is when they are moving side by side, or you can say they're sliding past each other. So I'm going to go through the rest of the slideshow. We're going to talk about each of these three examples: divergent, convergent, and transform, and talk about what can happen because of these plate motions. Now, one thing to keep in mind is that these three diagrams right here, are really nice diagrams. They help us visualize what it means by these plate boundaries. But in reality, tectonic plates are not this smooth. They are not all blocky like this. They're very rigid, and so they have lots of nooks and crannies. Especially when we look at convergent and transform boundaries, they can get stuck together because they're rigid. They're not straight like this, and so just keep that in mind as we go through and talk about the plate boundaries. First boundary we'll talk about is a divergent boundary. Again, divergent means two plates are moving away from each other. So the convection cells here are causing this plate to go to the left and causing this plate to go to the right. And so as you guys might have seen in your model, this creates large ridges because there are two plates moving away from each other. Large ridges are being created to in this boundary. And this also leaves the mantle exposed. So there's not, when the two plates move away from each other, you just don't end up with a bottomless pit. It exposes the mantle, and the mantle rock will actually melt and come up and fill up that ridge and sometimes form volcanoes. And so that volcanic activity is actually creating new crust, which will later be torn apart and make new room for new mantle, which will cool down and create new crust, which will be torn apart and create new mantle. It kind of goes in a cycle. So that mantle is called upwelling when that mantle is coming up between the crust to make when the mantle is coming up between the crust to make new crust. So let's look at an example of a divergent boundary. So the most famous example of a divergent boundary is called the Mid-Atlantic Ridge. So in the middle of the Atlantic Ocean, way deep beneath the ocean, is called the Mid-Atlantic Ridge. So the South American plate and the North American plate are moving to the west. The African plate and the Eurasian plate are both moving to the east, which creates this large divergent boundary going almost all the way down the globe. And so, if you guys remember, tectonic plates move very slowly. So these plates are very slowly separating, which means there is a gap that is forming and is getting bigger by about 3 or 4 centimeters a year. Now, one cool thing is that although most of this divergent boundary is underwater, in other words, there are these huge ridges underwater, you can see that part of it cuts through Iceland. I had the opportunity to go to Iceland a couple years ago. I didn't get to visit this boundary. I wish I had. But here's a picture in the lower right. You can see what looks like a river in between the cliffs. This is actually the Mid-Atlantic Ridge cutting through Iceland. And you can actually go pay to swim inside this ridge. So it's pretty cool to see that divergent boundary right there. Okay, so that's divergent boundaries. Let's look at convergent boundaries. Convergent boundaries are when two plates move toward each other. And so again, tectonic plates are very large pieces of rocks that have a lot of force and they're pushing toward each other. And so when you have one plate moving one way, the other plate moving the other way, they can't go left, they can't go right. They really have only two directions to go, either up or down. So when a plate moves underneath of another plate, that's called subduction. So this plate on the left side here is being subducted underneath the plate on the right, which means that this will actually go down and become part of the mantle. And it will actually eventually break off and melt and become part of the mantle. The piece on the left here is actually being squished upward. So again, this part is going down, but this part is going up. So when plates move up like this, they tend to become folded and all wrinkled, and we call those wrinkles mountains. So this is mountain formation. When two plates collide with each other, one thing that often happens is that you have these large mountain ranges. A very famous example of a convergent boundary is the Himalayas. The Himalayas has the tallest mountain in the world, which is Mount Everest. And if you guys don't know, the Himalayas is actually in a country called Nepal between China and India. So on this left side here, the theory is that India used to be its own landmass, its own island, and then this time scale here says millions of years, India moved across the ocean and crashed into the Eurasian plate. And now since they're both pressing up against each other, there are these huge mountains being created as a result of this motion. So that this convergent boundary, because these two plates are being pushed up against each other, they're actually making the earth fold up and create these large mountains. So if you ever listen in the news and hear about large earthquakes in India, well, it's probably because of this tectonic plate boundary, which is known for lots of earthquakes and mountain building. So that's divergent boundary, which moves apart from each other. And then this last boundary, we talked about convergent boundaries when two plates move toward each other. And the last boundary is a transform boundary, where plates slide past each other. So here, plates can either slide in opposite directions, or they can even slide in the same direction, but at different speeds. So remember, we're talking about huge pieces of rocks. So when two huge pieces of rocks, even if they move in the same directions but at different speeds, there's a discrepancy there that will cause some weird things to happen. So a really good example of a transform boundary where two plates are sliding past each other is the Andreas Fault. So part of California, most of California is on the North American tectonic plate, but some of it is on the Pacific plate. And those two plates are moving in different directions. One is moving toward the northwest, one is moving toward the southeast. And so transform boundaries are really well known for their earthquakes. Yeah, so here's what I'm talking about. The North American plate's going toward the southeast, Pacific plate's going to the northwest. So there is lots of earthquake scarring on the North Andreas Fault. Sometimes you don't really notice any deformation to the land, but they're often known for their large earthquakes. If you guys remember, I don't know, some of you might remember in the news that the San Francisco area had two really big earthquakes last summer. And that's because San Francisco and Los Angeles, they are right on this San Andreas Fault, which is one of the more well-known transform boundaries in the world. And here's more picture of the San Andreas Fault. And you can see that how distorted, these aren't really mountains, but the land has just become so lumpy and distorted because of what's happened in these earthquakes. And here you can even see canals have been shifted, roads have been shifted, because these plates are sliding in opposite directions. They're trying to get past each other. This curve here is just completely misaligned. So that is our discussion about tectonic plate boundaries. Let me just go back to the third slide to review. So we have three types of boundaries: divergent, where two plates move apart; convergent, when two plates move together; transform, where two plates slide past each other. One question on the exit ticket that usually confuses a lot of people is question number 5. So if you're working on finishing your lab, or if you're working on the exit ticket, question number 5 asks you, what is some empirical evidence you would look for to identify these plates? So I don't want you to tell me about the motions of these plates. What I want you to tell me is, if you were to go visit one of these plate boundaries, what is something that you would see that you wouldn't see anywhere else? And so just think about all the examples of these plate boundaries that we went over in this slideshow, in this video, and that will really help you with number 5. Thank you for watching, and hope you have a great day, and I look forward to seeing you guys on Tuesday. Bye-bye.